In our next session, we will take a look at a few different methods or just ways how we can deploy FTD. Similar to other areas associated with FTD terminology, that there is going to be some ambiguity that is related directly to the deployment nomenclature. And what I'm thinking in particular is going to be the term FTD mode, which refers to more than one aspect of the deployment. Actually, this term may mean two different things. One is going to be the operational mode of FTD, which is what we can set to routed or transparent. This is something that is also referred to as a firewall mode. And the role of this setting is going to be to control what types of interfaces that are going to be available in the configuration. As we will see, there are several different modes as how we can configure our physical ports, and which of them you will be able to select is going to depend on the operational mode setting for FTD. But we also have a functional area that is described as a mode of FTD, which is all about functionality or just capabilities that we want to use. Like, do I want to use intrusion detection prevention, or maybe do I want to use a firewall and IPS? So when you plan to deploy next generation IPS, it means that you're thinking about IPS only capabilities. When we aim for NGFW, it means that we think about using a firewall and potentially IPS. IPS in this case is optional. And now this mode of the FTD is going to be eventually determined by the configured types or just modes of the interfaces. So it's like that the operational mode, it controls available modes of the physical ports that we will be able to use during the configuration. And now what we configure is going to eventually determine whether we want to use IPS only functions, or maybe we want to use both firewall and IPS. Well, IPS in the second case is, as I said previously, optional. And now, speaking of those interface modes, so in the routed mode, you will be also able to configure routed interfaces. This is when you will deploy FTD in a pure layer 3 mode, where the device is going to be routing packets between the interfaces. Now, we can also go for an inline pair, or maybe deploy inline pair with a tab. And you can select the passive interface. And now, these three interfaces, this is how you will deploy next generation IPS. We will get back to this concept in just a second. Now, when you go for the transparent operational mode, or just transparent firewall mode, it means that you will be able to deploy your interfaces as switched ports /BVIs /transparent ports. These three terms are essentially referring to the same thing. Which term you will see, which option you will see in the GUI, will depend on the platform that you will use. Now, we can still go for the next generation IPS interface modes, inline pair, a pair with tab, passive, and passive with airspan. So this is something that was not available in the routed firewall mode. This is where you will use GRE to deliver a copy of the traffic to the FTD. Versus passive, this is generally talking about regular span or RSpan. Okay, we will get back to those different types of interfaces. I will explain how they work and what is going to be needed to use them, what are going to be the benefits and drawbacks. Okay, so setting the interfaces on the FTD is going to be pretty important since it will eventually control functionality and capabilities of our system. If we plan to go for the firewall function with an optional IPS, we will have to configure our interfaces as routed or transparent /switched /BVI. It is even possible to use the both types of ports on a single unit, which is known as integrated routing and bridging. Now, technically, in this case, the operational mode of the unit will have to be set to routed. So the firewall mode is going to be set to routed, but we will be able to use a routed and a transparent interfaces. Now, this is not supported on all platforms, so I didn't add the transparent switched PVI option to the previous slide for the routed mode, but you could potentially do something like this, and this way you would be routing the communication between the routed interface and between the BVI interface, which represents your layer 2 transparent subnet. Now, if you want to use IPS capabilities, you don't plan to use a firewall, you will have to go for one of these 4 interfaces, so passive or inline ports, where the difference between them will be primarily related to the way that the traffic was going to be flowing through the FTD. Like, do we get a copy of the traffic versus if it is real packets what are traversing through the device. And notice that it is even possible to mix interface modes on a single FTD unit. So this way you can use, let's say, routed interfaces for the firewall function, and you can use different interfaces like, let's say, inline pair to deploy IPS. So this would be an example of next generation firewall deployment. Now, from the design perspective, the separation of firewall and IPS functions may be useful in certain scenarios. And this is actually why they give us this possibility. We not only have to use firewall and IPS on a single unit, we can separate these 2 functions. I can still deploy 2 FTDs. One is going to act as a firewall and just the firewall. One is going to act as an IPS for the purposes that are mostly related to the performance of our platforms. And I say mostly because there are actually a few other reasons. Maybe you plan to follow separation of duties concept, like you want to separate the responsibilities. You want to have 2 different teams, threat prevention and firewall teams, so that different people handle different functions of your security appliances. It might be based on your security policy, but in most cases, it's going to be performance or just the amount of resources that we will want to use on one unit versus another for a given function. Like if I deploy a single FTD that will act as a firewall and IPS, it means that I have less control over resources used by one or the second function. So my IPS, in other words, could potentially starve firewall resources, leading to performance degradation. So at the end of the day, it will depend on the design of the network and also on the performance requirements. Probably the best way when you plan the functional mode of the FTD is going to be to take a look at the datasheet and see if the throughput limits, inspection limits, if they match your requirements. Going back to the firewall modes or just the operational modes of FTD, in case of the routed deployment, it means that our device is going to act as a layer 3 hop in the network, which means that individual interfaces of FTD will be configured as part of different IP subnets. They will be configured with different IP addresses, and the communication is going to be routed between them. So this means that our device is going to act as a regular layer 3 router when one of the FTD's interfaces could be potentially configured as a gateway to our clients. Now, in the transparent mode, what is going to be different is that our interfaces will not be configured with an IP address. They will be configured as part of a single bridging group, and there is going to be just one IP subnet, what we will deploy on top of that large layer 2 network that we will build by bridging different interfaces together, where one of the addresses that belong to these subnets is going to be configured on the single transparent FTD virtual port BVI, a bridged virtual interface. And this is what is going to allow FTD to participate in layer 3 routing from the subnet. Like for example, when you want to allow FTD to reach some external servers that are available across multiple layer 3 hubs in the network. And maybe let's take a look at this in the doc.cd. I'm going to open up configuration guide for 6.2.2, and we will take a look at a firepower threat defense config basics. It's going to be this document, transparent or routed firewall mode for FTD. So just to make sure you understand the differences between the two modes, let's take a look at this drawing. This is an example of how transparent configuration, transparent mode deployment could potentially look like. We have a bunch of hosts connected to a single VLAN. We also have a router which is acting as a default gateway to reach the internet. Now from the physical setup standpoint, or just layer 2 standpoint, we are using two different VLANs between the hosts and the gateway. Like let's say that this is going to be VLAN A between FTD and the router, and we are using a different VLAN at the bottom. Now the reason why we will use a different layer 2 networks here is because we want to force the communication to go through the FTD. So we want the traffic to flow in this direction, at least when the hosts want to talk to the gateway. And now what we will do on the FTD is that we will use two separate physical interfaces like GIGO1 and GIGO2, and we will make these two interfaces part of the same bridging group. Like you will say that this is a bridge group number 1. You will then build a bridged virtual interface with the same number. So these numbers must be the same. And this is where you will put your IP address on the BVI, not on the physical ports. And now as a result of doing something like this, instead of using two separate layer 2 networks, it's that you merge those networks. You build a large broadcast domain, a single broadcast domain, but the traffic flowing between these two portions of this domain is going to be controlled by the FTD. So it's the same exact concept as what we saw on the ASA. If we take a look at this documentation, at those different sections related to BVI and the transparent mode configuration, restrictions, limitations, it is exactly the same what we saw with the ASA. So I'm not going to go through those different sections, like, allowed addresses, what traffic is by default allowed to pass through the transparent FTD. This was all covered in the perimeter security section when I was discussing the ASA firewall modes. The same set of limitations like unsupported features, supported features, it's the same document. The firewall mode is something that we will configure during the initial setup, but it will be always possible to change it using the configure firewall command. But if you decide to do something like this, you have to remember about two different things. One of which is going to be to first and foremost unregister FTD from the FMC. The device will not allow you to change the firewall mode while being registered. And second is that when you eventually change the mode, so you disconnect it from the FMC, you issue the configure firewall command, it is going to automatically wipe out all existing configuration. Speaking of benefits and drawbacks of one or another firewall mode, it's going to be the same stuff as what we saw with the ASA. When we decide to go for the routed firewall mode, it will be pretty hard to add FTD into the existing infrastructure because it will require a changing IP addresses on all devices connected to the segments where FTD is going to be eventually inserted. So stuff like this is not going to work in every single environment. It might essentially take too long to rearrest all the devices depending on the number of the servers you have and the overall design. Now, the benefit of this mode is that all firewall features that you can potentially use on FTD, they are available for configuration. Well, except one or two features that are related to the transparent mode. But stuff like VPNs, like routing, like multicasts, it is all supported when you go for the routed firewall mode. Now, in case of the transparent FTD, it will be pretty easy to add a new FTD to the network because you will not have to change any IP settings on the existing devices, like on the servers, on the gateways. This stuff is going to be the same, which is one of the main reasons why this mode is commonly used in the data centers. So just to give you an example how you could actually deploy FTD in a data center, like assuming that this is going to be our switch, which is acting as a gateway to the connected servers, say S1 and S3. We have a bunch of servers and they all point to the switch. They use it as a gateway. And we are using a single VLAN, let's say VLAN A, and those devices are all in the same subnet, let's say IP subnet A. So if you were to change this design, if you were to add FTD to enforce a policy, what you would have to do is that you would keep all the addressing information. So IP subnet would be the same, doesn't change. Now you would then keep this VLAN on the switch to FTD connection. I am putting FTD into the middle here. I would keep VLAN A over here, and then I would just switch a VLAN from A, let's say, to B on this portion of the network, and my servers will be still pointing to the same gateway's IP address. Their addresses also don't change. So the only thing that would be different here after adding FTD would be the addition of a, in this case, single VLAN to accommodate a second interface of the next generation firewall. But as you guys probably know, this benefit of easy integration comes with a cost. FTD in the transparent mode does not support all the features, like for example dynamic routing, QoS, VPN, DHCP relay. So there are a few different features that are still not supported. It's a Zephyr channel. So before you deploy it, you want to take a look at this table to see exactly what's unsupported. Okay, also don't forget that when you plan to deploy next generation IPS, so you want to use IPS capabilities without having a firewall, you can still enable this regardless of the operational or just the firewall mode, because next generation IPS interfaces are supported in any of these two modes. Now let me also quickly discuss the differences between the passive and inline IPS deployments. So this is when you plan to use IPS functions without using any of the firewall features. In this case, you can go for a passive interface, in which case you will have to somehow copy the traffic from the network to FTD, to FTD's interface, configured as a passive port, which generally means that you will have to use span, remote span, or ER span, as long as the passive interface was configured as passive ER span port. But don't forget that this type of configuration, choosing the passive interface mode, is going to make your FTD an intrusion detection system, but not a prevention unit. So what it means is that you will see the attacks, but you will not be able to use FTD itself to block or just drop those offending packets. You will not be even able to normalize those packets, because it doesn't make any sense to block or normalize a copy of the traffic. The real packets would still make it to the victim. And this is going to be different with inline deployments. which is configured by correlating two interfaces into a interface pair. And as a result of doing this, the traffic received on one interface in a pair is always going to be forwarded for the other port in the pair. And now an important thing to understand is that even though it is somewhat similar to what transparent mode forwarding does, like when you deploy transparent mode interface on the FTD in the transparent firewall mode, this configuration is going to force FTD to act more of like a layer 2 device, where FTD is going to be using its CAN table to switch the packets. So it will have to take a look at the frames layer 2 destination MAC address to figure out which of the bridged interfaces to use to forward a packet. So this is a switch-like behavior. Versus with inline pair, like when we have two interfaces, I'm going to say port number 1 and port number 2. Anytime I'm going to get a packet on interface 1, I'm going to simply replicate it out of the second interface in the pair, and vice versa. So in this case, this is more of like a layer 1 mode, because the device acts as a repeater or sort of a two-port hub. And what it gets on one interface, it forwards out of the other. It doesn't even look at the layer 2 information in the frame. The main difference from the previous, the passive mode obviously is the ability to not only detect but also stop the attacks. Since inline IPS sits in the data plane, it receives real communication flows. It can drop or normalize packets, and this way protecting potential victims from attacks. I will be showing you configuration in a different session, but in general, all interface related settings, you will be configuring them from the devices and device management tabs. And specifically for inline sets, you will have to bind your interface pair or interface pairs, because you can have more than one into an inline set, which is then going to be used in the configuration. Previously, I also mentioned that the inline pair mode can be configured with the tab setting, which is technically what is going to make your inline IPS a passive detection system. When you deploy inline pair with tab interface, the device still technically sits inline with the real packets, but it will never affect them even if your policies tell it to do so. So this is effectively, well, maybe not passive, this is effectively making your device an intrusion detection system. Why you would actually use a mode like this? It's just to test your policies. So for example, you want to cable the network as if it is to support the real inline pair configuration. So you want FTD to sit in the data plane. But before you switch to the real inline pair mode, you want to see what your FTD would actually do on the packets in the log messages based on your current policy configuration. So it can be thought of more of like a monitor mode that is going to be useful to pilot inline deployment before really affecting the traffic.